To continue our discussion of the fundamentals of programming, we've covered the basics of values and expressions and the different types that they can take on. Now we'll talk about variables, which are labeled space in memory that holds values, where after doing one calculation, we store the result in a variable and then use the value of those variables in subsequent calculations. Variables let us use a name instead of having to always refer to the specific value. To create a variable, we use what's known as the assignment operator. It's just the equal symbol that you're familiar with. This both creates a variable and stores a value inside of it. Returning to our interpreter, a simple example of a variable will be something like x equals 2. Note spaces are not necessary. You can say also just x equals 2 without the spaces. We can check that this process worked by asking now, what is the value of this symbol x? And we can see the interpreter knows this to have the value 2. We can change that value. We can say x equals 3 and ask again, and now x has the value 3. The assignment operator has low precedence. It's typically done last in any expression. For example, I can say total equals 1 plus 2 plus 3 plus 4. And this says evaluate the sum of 1 plus 2 plus 3 plus 4, 10, and take that result and store it in a new variable called total. So now if we ask what's the value of total, notice it doesn't say that whole expression. It says just the result of that expression. When using variables, you can think of them like a box with a name. Assignment means put a value in a box and put a label on it. Using the variable means we're just pulling the value that's stored inside that box. A variable name can be used wherever we would normally use its value. For example, x times 5. So because x has the value 3, x times 5 has the value 15. Notice the value of x wasn't changed through that operation. It says grab the value from x, which in this case is 3, multiply that by 5, and return this new result. But it didn't say put anything back into the variable. If we'd like to change the value of a variable, we need to reassign to that variable. So it needs to appear on the left-hand side of the assignment operator. So you could say x equals x plus 1. And now x equals 4. Also note that there is a distinction still between the string x and the variable x. Even though variable names all use the characters that we're used to seeing in text, if they're not enclosed in quotes, Python will interpret them as a variable name, or an attempt thereof. Let's consider another example here. Say x equals 10 and y equals 20. If I then said x equals y and y equals x, what are the values of x and y? So pause the video, think your way through this, and then unpause. Welcome back. So what is the value of x? Well, x equals y and y equals x. It seems as though we're swapping those two values. So x equals 20, and if we ask what y is, we might expect it to be 10. However, the value is still 20. The reason for this is because Python's executing these lines one step at a time. So the first two lines go as we'd expect. Creates a variable called x with the value 10, and creates a variable called y with the value 20. At the third step, where it says x equals y, that says take the value of y and put that into x. So the variable x, which was holding 10, now holds a 20. Notice it didn't say anything about changing the variable y, so that is also still 20. At that point, the value 10 is lost to us. The next line, which says y equals x, says copy the value of x, which is now 20, and store it back into y, which already had 20, effectively doing nothing. The end result is that both numbers are now 20. One of the major benefits of variables is that they allow us to express things in a more general way. As an example, consider our challenge before where we wanted to print 12 times 13 equals, and then the result of that, which was 156. The solution we came up with, or one of the solutions we came up with, was 12 times 13 equals, and then the result of that, so 12 times 13. And that printed out our expression. Now the benefit of variables is that they allow us to create placeholders for values that change over time. So we can say a equals 12, b equals 13, our two input values, but now stored as variables. And we can print the entire expression. We can say print the string of a times the string of b equals, and then the string of multiplying those two things, a times b. And that gives us the same answer we had before, perhaps in a more complex looking way. But now we can say something like a equals 786, and b equals 92. Oops. B equals 92. Press up on our keyboard to get our previous statement back, and without typing anything, so without changing the expression at all, we get a different output because the inputs were different. This is a style of programming known as imperative programming. It's coding based on the changing of variables over time, and this underpins pretty much all of modern programming. Now, to really understand what's going on with variables, it's important to note that there are three main parts of a variable. There's the value that we're storing, there's the name we're storing it under, and there's the memory we're storing it in. So let's go through each of these in turn. The value is everything on the right-hand side of the equal sign in the assignment statement. So in this simple assignment statement, x equals 2, the value is just 2. The value can be any sort of expression, literals, operations, or other variables even. So examples, we can say I equals 2, the value there is 2. I can say j equals I, the value there is the value of I, which in this case is also 2. I can say k equals I times j. The value there is the result of I times j, 2 times 2 in this case, so 4. So we ask, what is the value of k? It has the value 4. Self-referencing assignment statements, as we've seen, are also okay. So k equals k plus 1. No problem there. And now k has the value 5. This again says evaluate the right-hand side. So the value is k plus 1, or 4 plus 1, which is 5. And then store that back where we started. If I run that same expression a second time, it means something slightly different because the k has changed. So now it's 5 plus 1, and that gets stored back in k, the result being 6 now. It's also important to note that in Python, variables can have any type of value. So I could say k equals 2 times 3, which is an integer, because it was already there. I could also say k equals hello plus world plus exclamation. And now k is a string, the same variable name at least, storing a different type of value. This is different from other languages like Java or C, where variables are declared to have a specific type. An integer variable can only hold integers, and a string variable can only hold strings. This is what's known as static typing, as opposed to Python's dynamic typing. The second part of a variable is its name, otherwise known as its identifier. Now, there are rules in Python for what makes for an allowable name, and also some good conventions to follow when making names. Variable names in Python can be any combination of letters, numbers, or the underscore character. Importantly, these are case sensitive, so any combination of upper and lowercase letters. So the variable a is different than the variable uppercase a. Another important rule is that variables are not allowed to have spaces. So I can't say, for example, my dog is Cecil. That is both untrue and a syntax error. While variable names are allowed to have numbers, so for example, I could say student1 equals Alice and student2 equals Bob. Variable names, however, are not allowed to start with a number character. So I can't, for example, say 3 student equals Charlie. The error we have here says invalid decimal literal, which means Python saw a 3, thought the rest of this thing would be a number, and says 3 student isn't any number I'm used to seeing, so I can't make a number out of this. Python does permit the underscore character to begin as symbol, so I could say something like this, underscore 3 student Charlie. That's perfectly allowed. It's bad practice, but it is allowed. The underscore character as the beginning character in a variable typically has special meaning. We'll talk about that much later in the course. In Python, no special characters other than the underscore character are allowed in variable names. So while I am allowed to say something like a underscore variable equals hello, I'm not allowed to say variable exclamation equals hello. Any symbols, so brackets, dollar signs, percent signs, asterisks, anything that isn't the underscore is not allowed in a variable name. There are also some combinations of the allowable symbols, so words, for example, that are not allowed to be used as variable names, and these include words that already have important meanings. For example, the word true already has the value true. It's a constant. So this is what's known as a reserved word. If I try to say true equals 5, in Python 3 at least, you're no longer allowed to do that. Cannot assign to true. Now, it's important when writing code to choose variable names that are meaningful to the code that you're writing. For example, if I'm creating a self-driving car and I have a variable that controls how fast the car is going, I probably shouldn't call it size or color. I should call it speed or velocity, as those make more sense. As an example, consider this variable name. If you saw this in your program, remembering that programs typically are many hundreds of lines of code long, it wouldn't immediately make any sense to you. In fact, it is a meaningless variable name. The other downside of this is you have to remember the exact nonsensicalness of that variable name when using it. Consider instead this variable name to represent the same value in the same program, NSIC. Now this is the short form for 4 words, so the first letter of each word, that at the time I was writing this, I knew what it meant. NSIC equals 70. But then I walk away from my program, I come back, and I see this symbol, NSIC. It has no context, no inherent meaning, because it's just a few letters. A more valuable variable name is one that is self-commenting. It's one that explains what that variable does. If you have multiple words, you can run them all together. Num students in class equals 70. And now we understand this variable represents the number of students in a class. It's a slightly hard to read variable because the individual words are still difficult to distinguish. So one thing we can use instead is what's known as camel case convention. It's to uppercase the first letter of every word in our variable except the first. So we'd say num students in class. This is slightly more clear than the previous, as it doesn't rely on a person's interpretation of where those words are separated. Another alternative to this is what's known as snake case, perhaps a bit more Pythonic in that regard. So I could say num underscore students underscore in underscore class. So instead of capitalizing the first letter of each word, we separate words with underscores to achieve the same effect. That's not my preference because it ends up being more characters, as you can see, although it does end up also being a bit cleaner to read. Either camel case or snake case is fine in your own code, although it's strongly recommended to pick one and stick with it. If you're switching back and forth between them, the result will be less readable code. The third part of a variable is the actual memory itself. So variables can only hold one thing. And if a variable is a box that can only hold one thing, then memory is like a long sequence of boxes, kind of like a community mailbox, where each one has its own address. When we create a variable, 2 things happen. First, we declare that variable, and the second, we initialize that variable. So to declare is to associate a name with an address in memory. So we call this box XYZ, for example, and then Python will remember that anytime a program refers to the symbol XYZ, it refers to a box with this specific address. The second step is we initialize. So we put the actual value in that space in memory. In this case, we say this box holds the value 100. Now this happens every time we create a variable. These variables may not be side by side like in this image, as memory tends to be many times bigger than this image depicts. We can see this in our terminal. In Python, when we create a variable, such as xyz equals 100, we can check the memory address by using the id command. So the letters id, round brackets, and inside those round brackets, the variable we want to check. And this tells us the space in memory where Python has decided to store our variable. Now what happens in memory when we reassign a variable? We've seen that variables can only hold one value at a time. So if we assign new values, we have to get rid of the old ones. Conceptually, what we're doing is we're taking the old thing out of the box and putting a new thing in that box. But actually what Python's doing is making a brand new variable each time. So if I said xyz equals hello, it creates a new space in memory, stores the value of hello there, and assigns it to our symbol. Notice the old value still sits in memory for a little bit. It has no way to be accessed, so eventually Python's memory management will say this is garbage, so we will collect it. Returning to our terminal, we can verify this. So we have xyz as our variable name, and we can see its current memory address. If I say xyz equals a new value like hello, right, it now has that value, and I can check where that's stored, and notice it's in a very different place. Now you might ask, why make a new variable instead of just replacing the old one? The most obvious reason is because of dynamic typing. The amount of space required to store a small number, like let's say 100, is very different than what we would need to store a large string, like let's say the word hello. So Python's design is just to make a new variable for everything, and that way it saves having to figure out when should we move things and when can they be reused. Python also has an optimized way of assigning variables for small values that happens to share memory locations. So for example, if I said something like x equals 1 and y equals 1, the ID of x and the ID of y are very often the same. I can now say x equals 2. I know that that has changed. It's in a different location. This is what's known as interning. This is not necessarily part of the course, but it's helpful to understand why Python does the things that it does. Now notice the variable has to move when we reassigned it. Since y is also pointed at that same memory location, we would end up changing 2 variables instead of 1. So rather than doing that, Python creates new variables every time you change the value.